Alright guys, well welcome back to class. In this first lesson we are just going to go over the addition and subtraction identities. I will show you what they mean and I will show you how we prove that they're true and how we found them. So starting off, let's look at these identities that are written up here on the screen. So first of all, we've got cosine alpha beta equals cosine alpha cosine beta. Now you'll notice in your trig identities, if you do not have this worksheet, there are copies of it on my Open Math, so go ahead and print those off. There's also a blank one that I use for the quiz. You can print off a couple of those so that you can practice memorizing those. Okay, but let's look at this cosine one first. So we have cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha plus sine beta. So what I want you to notice about cosine is very organized. It's cosine, 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 sine, sine. So cosine equals cosine, cosine, sine, sine. That's true for both of them. So the basic layout of the cosine is the same. Also, I want you to notice that the alpha and betas are the same. All throughout everything. It's always alpha, beta, alpha, beta, alpha, beta, all the way through. Alpha, beta, alpha, beta, alpha, beta, alpha, beta. Okay, you get the idea. They're always in that same exact order, so you don't have to worry about changing any of those. The only thing about cosine is that cosine has a different sign. So that's what is a little messed up about the cosine. So the trig function, the trig identities the trig functions are very organized, cosine, cosine, sine, sine, but the signs are different, a minus and a negative. Or minus becomes a plus. Then on to sine. What you notice about the sine function is that it's the trig equations that are messed up. So now we have sine equals sine cosine, cosine sine. What do you notice about the sine now? If it's plus here, it's still plus in here. So for sine, just remember the sign is the same, but it is those trig functions that are messed up, right? So sine starts with sine and ends with sine. So sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta, right? And then on the subtraction one, alpha minus beta, the signs are the same, and sine starts and ends with sine. Okay, so do work on memorizing those. And you'll be working with those formulas plenty. You should be able to figure them out pretty easily after this lesson. Okay, so now I want you to look at this picture down here. And what we have is we have two triangles. And where we started with this picture is we started with the angle alpha. Now, the angle alpha is that interior angle. Get a bigger pen here. This full interior angle. So starting at the x-axis and going all the way around to P. That is the angle of alpha. So if we wanted to write the value for the point of P, P would be cosine alpha, sine alpha. Okay? Then the next one that we're going to look at is the angle of beta. Beta is just the smallest angle right here. And the line that is drawn from that angle ends at Q. So the point Q we could write as cosine beta sine beta. All right, so far the angles that we've been working on are either angles that are on the unit circle or we've used our calculator. But what we're going to show you now is how to find angles that are not on the unit circle, but still be able to use this unit circle and to not use your calculator. That's where these identities, why these identities were written. Okay, so what that tells me is I want to know an angle such as the angle of alpha minus beta. And where this angle comes from, this is actually the angle drawn out by the triangle POQ. And it is going to be that interior angle that is set at the origin. Okay, so now this triangle is representing with this interior angle alpha minus beta is right here. Okay, so that's the angle alpha minus beta. Now this is pretty hard to work with on one of our unit circles, but what I can do is I can now rotate this triangle and I can place that left-hand side or that right-hand side of the triangle onto the x-axis. So just rotate that triangle and then what we get is our green triangle. Oops, whoops, go back. Let's try that again. We want to go all the way down here and here. Okay, so it's the same exact triangle, so what I can say is that triangle POQ is congruent to triangle COD. Okay? And then from there, because I know those two triangles are congruent, I can also say that the line PQ is congruent to the line CD. And if you remember, that's the congruence part, congruence pieces of triangle theorem from geometry. So because we know that, we know those two lines are equal to one another, we can use that information to get the formulas that we have. So I need to know what this point C is. Now remember, C is just the rotated version of P after we took the alpha minus beta. So the point for C is going to be cosine of alpha minus beta, and the sine of alpha minus beta. Okay? And then our point D, we also need to know what our point D is, but that's very nice and easy, just the 0.10. Okay, so let's go ahead and go up here. I'm going to get a smaller pen here. And we are first going to look at the line PQ. So to prove these identities, I'm going to take these two lines and I'm going to use the distance formula to show where this identity comes from. Alright, so I'm going to take the square root, and I'm first looking at P, so I'm going to take the difference in my x values and square them. So that's going to be cosine alpha, minus cosine beta, and square that, and then add the difference in our y values, which is sine alpha minus sine beta. That one looked a little bit better. Okay, now when I square these out, I'm going to use this property. Remember when we have a minus b squared, that's going to equal a squared minus 2ab plus b squared. Alright, that's a property I'm going to use when I square these out. Alright, so now let's make that just a little bit bigger. Let's see if I can still read my writing. Alright, okay, so equals the square root of, okay, that's much better. Okay, so the cosine squared alpha minus 2 times a times b, which in this case is cosine alpha, cosine beta, okay, plus cosine squared beta. Alright, now I'm just going to add on the second part underneath here. So plus sine squared alpha minus 2 sine alpha sine beta, okay, plus sine squared beta. Okay, so that's everything squared out and underneath that radical sign. So now what you'll notice, which is very nice for us, is we have a cosine squared alpha right here. We also have a plus cosine squared beta. No, that's not the one. We have cosine squared alpha plus sine squared alpha. There we go. And then cosine squared beta plus sine squared beta. What do you notice about that? That is our Pythagorean identity, which comes in very, very handy, as we can take that plus that, cosine squared alpha plus sine squared alpha, and say that that is equal to 1. All right? Then we've got cosine squared beta plus sine squared beta, which is equal to another 1. Then what's left is 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Okay, so I'm going to just real quick here erase my 1's and just make that a 2. Okay, so simplify there. All right, very good. So that was our first one, and I am going to erase this just to get it out of my way so I have room to do the next identity. Okay, and so our next one we've got to do is the length of CD. Okay, so CD, this is going to be even longer. It's probably going to take me 2 rows to get to this one too. This one, we are going to have C, which is, point C has the x value of cosine alpha minus beta, all squared. No, not yet. Don't square it yet. That is just our first x. So cosine alpha minus beta minus, remember what we had here. I'm going to write my point back in here. It was the 0.10. So we have cosine alpha minus beta minus 1 all squared plus sine of alpha minus beta minus 0 Okay, let's go ahead and finish off. So we're going to square that last one for y. Sorry, my computer died and I had to get it plugged in, but it looks like my video is saved. So I'm really happy I don't have to start over again. All right, so again, we're going to use that squaring identity to square all of this. So we have cosine squared of alpha minus beta minus 2 cosine alpha minus beta canon. Okay, looks like I have somebody in the background now. Didn't notice that. Plus 1. And then for that last one, we have just minus 0, so that's going to end up just being sine squared of alpha minus beta. Okay, so we have cosine squared alpha minus beta, sine squared alpha minus beta. That's all going to equal 1. So we have the square root of 1 minus 2 cosine alpha minus beta. So what we would do from here is set